we are asked to solve the right triangle shown below. So figure out all the angles and all the sides. And let's start with the angles. Let's try to figure out what angle y is equal to. So I'll give you a few seconds to think about that. Well, if you just remember that angle y plus the other two angles, those are going to be the sum of all of the angles in the triangle. And the sum of the angles in any triangle have to add up to 180 degrees. And so we just have to solve for angle y now. We get angle y plus 150 degrees is equal to 180 degrees. Subtract 150 degrees from both sides, you get angle y is equal to 30 degrees. Is equal to 30 degrees. Now we can go about figuring out the lengths of side A and side B. And it immediately jumps out that this is a 30, 60, 90 triangle, which is a type of triangle that we see at least in a lot of math classes. But I'll let you decide how you can figure out the length of side A. And I'll give you a few seconds to think about it. Well, I'll do it two ways. One is I'll assume that we know our trigonometric ratios, and then we can figure out side A that way. And then the other way, I'll assume that we know a lot about 30, 60, 90 triangles, and I can solve it that way. And actually, in my mind, the 30, 60, 90 triangle way is a little bit easier. But let's do this way, since we're kind of involved in doing trigonometric functions or using trigonometric functions. Let's use trig functions to figure out what A is. So we could use either of these angles. Let's use, I don't know, we could use 60 degrees. That's what they gave us. So let's look at this 60-degree angle right over here and say, well, okay, we know the angle. We know the hypotenuse. This right over here is the hypotenuse. It's opposite. It's the longest side of the triangle. It's opposite the 90-degree side. It's opposite the right angle. And A, length A, this is the length of the adjacent side for this angle right over here. So what trig function deals with adjacent and the hypotenuse? Well, to remember, let's rewrite SOHCAHTOA. SOHCAHTOA. Well, cosine deals with adjacent and hypotenuse. Cosine of an angle is equal to the adjacent over the hypotenuse. So we can write cosine of 60 degrees. Cosine of 60 degrees is equal to the adjacent side, the length of the adjacent side, which is A, over the hypotenuse, which is equal to 10. And if we want to solve for A, we can just multiply both sides times 10. Both sides times 10. And we're left with A is equal to 10 times cosine of 60 degrees. Now, if you were to type cosine of 60 degrees into your calculator, you'll get to this big decimal number. But cosine of 60 degrees is one that comes up a lot. It is actually good to know the sine and cosine of 60 degrees, 30 degrees, 90 degrees, 45 degrees, because they come up so much. And oftentimes you might want to express your answer not as a decimal, but as some type of radical expression. So here, and this is just a good thing to know, the cosine of 60 degrees is 1/2. Cosine of 60 degrees is 1/2. And I guess for the case of 60 degrees, cosine of 60 degrees, your calculator would have done the job and given you a very exact answer, and we could have shown that to you. So if you were to just say cosine of 60 degrees, you get exactly 1/2. But this is one that I normally don't tell people to commit a lot of things to memory, but this is a useful thing to commit to memory, that the cosine of 60 degrees is equal to 1/2. So if the cosine of 60 degrees is equal to 1/2, A is equal to 10 times 1/2, which is equal to 5. So A is equal to 5. Now let's think about what B is going to be equal to. Well, once again, we can use our trigonometric ratios, and we could use either angle over here, but let's stick to the 60-degree angle. B is now the side that is opposite the 60-degree angle. So what trig ratio deals with opposite and hypotenuse? Well, sine deals with opposite and hypotenuse. So what is B going to be equal to, assuming that you know what the sine of 60 degrees is? Well, let's think about it. We know that sine of 60 degrees is equal to the opposite side, which has length B, over the hypotenuse, which has length 10. Well, multiply both sides by 10, and you're left with B is equal to 10 times the sine of 60 degrees. And this is one where if you put sine of 60 degrees in your calculator, you're going to get this long, you're going to get a decimal. But this is one that's also good to commit to memory. The sine of 60 degrees, especially if you want to give your answer in kind of a radical expression. Sine of 60 degrees is the square root of 3 over 2. Once again, just a good thing to commit to memory. There's no way of kind of, well, if you know about 30, 60, 90 triangles, you could actually prove this. But for the sake of this problem, we'll just know that the sine of 60 degrees is square root of 3 over 2. Once again, another good thing to commit to memory. So if sine of 60 is square root of 3 over 2, square root of 3 over 2, b is equal to 10 times the square root of 3 over 2, which is equal to 5 square roots of 3. So it's equal to 5 times the square root of 3. And we're done. Now, I pointed out that if we know about 30, 60, 90 triangles, which do show up a lot in math, and so we should know about them, we could have done this without using the trigonometric ratios. And in fact, the way that I remember the values of cosine of 60 degrees and sine of 60 degrees and cosine of 30 and sine of 30 is essentially by knowing about 30, 60, 90 triangles. So in general, this is just an alternate way to solve the exact same problem. In a 30, 60, 90 triangle, this is true for all 30, 60, 90 triangles. So this is 90 degrees, this is 60 degrees, and this is 30 degrees. If your hypotenuse has length h, then your 30-degree side, the side that's opposite the 30-degree side, I should say, which is the shortest side, is going to be exactly half the hypotenuse. So this is going to be exactly half the hypotenuse. And then your 60-degree side is going to be the square root of 3 times the shortest side. So it's going to be the square root of 3 times the hypotenuse over 2, or square root of 3 over 2 times the hypotenuse. And in other videos, I go through a proof of how this happens. You really just have to construct an equilateral triangle like here, where the lengths of all of these are h, and you can come up with this. But if you know this general principle of 30, 60, 90 triangles, that whatever the hypotenuse is, the side opposite 30 degrees is half of that, and the side opposite 60 degrees is square root of 3 times the shortest side, then this whole solving the triangle becomes pretty simple. The hypotenuse is 10. The shortest side, which is opposite the 30-degree side, well, that's going to be half of it. So that's going to be 5. And then the side opposite the 60-degree side is just going to be square root of 3 times the shortest side. So it's 5 times the square root of 3.